Hey guys, welcome back to another video lesson. This is L23. This is found in 10.6 of the textbook if you want to follow along in the textbook. And we're looking at segment relationships in circles today. So there's going to be three different cases, and each case has its own theorem. And so just like before, what I'm going to do is just read the textbook theorem, like right out of the textbook, but then I'm going to explain it, and we're going to draw our own pictures. So as I draw, please go ahead and draw whatever I'm drawing, write down whatever I'm writing down. And then we're also going to have about 2 or 3 examples for every case, just so it really sinks in. Okay, so 3 different cases. Okay, so here we go. The first case, I like to call it, case number 1, 2 chords meet inside of a circle. And here's the textbook definition. Theorem 10.18, segments of chords theorem. If 2 chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. Okay, so what's happening is you can see in this diagram, you have this circle, this nameless circle, okay, and there's a chord, chord DC, and there's another chord, chord AB. Well, these 2 chords intersect inside the circle at point E. And so if you look at, for example, chord DC, it gets broken up into 2 smaller, what are called segments of the chords, right? So here's a segment, segment DE, and here's a segment, segment EC. So this chord gets broken up into 2 smaller segments, okay? And same thing, segment AB, this chord gets broken up into segment AE and segment EB. And all this theorem tells us is that the relationship is that these 2 segments, if you multiply them together, segment DE times segment EC, their product is exactly equal to, okay, these 2 segments when you multiply them together, AE times EB. Okay, so let's go ahead and draw this on our own. Okay, so you have a circle, and the circle is just sitting there minding its own business, and inside of the circle you have 2 chords. Okay, so let's go with this chord first. Let's call that segment AB. So chord AB is inside of the circle, and then there's another chord right here. Okay, and this is chord, we'll call it chord CD. And these 2 chords intersect right here at this point, point E. Okay, so the little catchphrase or the moniker that I want you to memorize, okay, that goes along with case number 1, is you multiply the pieces. That's all you have to do. That's all you have to do. That's all you really have to remember. Once you identify this picture, you multiply the pieces. Well, which pieces are we talking about? We're talking about the pieces of each one of the chords. So first of all, there's chord AB, and there's 2 pieces. It got cut into 2 pieces. So multiply the pieces. So AE, that's this piece here. Okay, AE times EB is equal to, and then now on the other chord, chord CD, that got cut into 2 pieces also. So here's one of the pieces, CE times ED. And that's all you have to remember. You simply multiply the pieces. Okay, this is what you have to remember. Okay, so let's go ahead and do 3 examples. Okay, so here's some examples over here. Number 1, find the value of x. So what's going on? First, just look at the big picture. The big picture is you have a circle. Okay, now look at the details one at a time. You have this thing, which is a chord, and you have another chord, and they both intersect. They intersect each other inside of the circle right here. So what is the catchphrase? What is the moniker we have to remember? Right here. Multiply the pieces. Multiply the pieces of the 2 chords. Okay. So let's go with this piece first. So I have 4 times 6 is equal to, and now I multiply these 2, x times 3. So 24 equals 3x. Dividing by 3, I have x equals 8. Alright, now let's make it a binomial. Let's make it a little bit more complicated. That was too easy. Okay. The picture, though, is the exact same. Okay, it's case number 1. You have a circle. You have this chord here, sort of horizontal-ish chord. Then you have this vertical kind of chord, right? So what is the moniker? Right here, multiply the pieces. That's what we apply to here. Okay, so for this vertical chord, it's not really vertical, but this upright chord, 3 times 4 is equal to 2 times the entire x plus 1. Okay, so we have 12 is equal to, and what do we do with this? Our old favorite, distribution. Distribute the 2. Now we're going to subtract the 2, subtract this 2 over here. Okay, so 10 equals 2x. Now we're going to divide by that 2, so x equals 5. And are we done? Yeah, we're done. It just said find the value of x. Okay. Alright, now in this example, number 3, it asks us to find ML and JK. So we're not just solving for x, we need to solve for x and then plug that back in to answer the question, to find ML and JK. Okay. So let's look at the diagram. Okay. And this is case number 1, yet again. You have a circle and 2 chords that intersect inside of the circle. So what is the moniker? Multiply the pieces. So here we go. So on this chord here, I have x times x plus 4. On this chord here, I have x plus 2 times x plus 1. So let's go ahead and distribute. X squared plus 4x is equal to. Now how do you multiply 2 binomials? Well, some of you might have learned it as FOIL, first, outer, inner, or last. And some of you might just think of this as double distribution. Since I know that most of you are very, very familiar and comfortable with distribution, I'm just going to distribute the x across both terms, and then I'm going to distribute the 2 across both terms, and then just combine like terms. Okay? So first let's distribute this x right here. So x times x is x squared. X times 1 is 1x. Now I distribute the 2, positive 2. 2 times x is 2x. 2 times 1 is 2. So I'm going to combine these like terms, x and 2x. Okay? So x squared plus 4x equals x squared plus 3x plus 2. Now I can subtract x squared from both sides of this equation, so that'll eliminate those two. So I get 4x equals 3x plus 2. And now I can simply subtract 3x from both sides of the equation, leaving me with x equals 2. I got x. Am I done? No. Go back and answer what the question is asking you to answer. So ML. ML is x plus 2 and x plus 1. Okay? So x plus 2 would equal 4. X plus 1 would equal 3. So ML equals 4 plus 3, which equals 7 units. JK would be x equals 2, x plus 4 equals 6. Would be 2 plus 6, which equals 8 units. And now we've answered what they've asked us. There's ML and there's JK. Okay, feel free to pause, rewind, do whatever you want, stop the video, okay, at any time, okay? But I'm going to keep moving on. Okay, so the next case is, in the book, it's theorem 10.19, segments of secants theorem. So you have to remember what a secant is. A secant is a line or a line segment that intersects a circle in not 1, but exactly 2 points, okay? So here we have a circle. It's this nameless circle. The authors didn't name it. Not nice. Oh well. And then we have this top secant, right? The segment EB is a secant to the circle. How do we know? Because it intersects it at 2 points, A and B. And then from that same point E, we have this other secant in the bottom here, segment ED. We know that's a secant that intersects the circle at CD. Okay? So let's read the theorem and explain it. If two secant segments share the same endpoint, E, outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. Okay, so what is this thing, external segment? Okay, so you see this bottom secant, right? This bottom secant, segment ED. That whole thing is a secant to the circle, right? But it has two kind of pieces to it, right? There's this part, CD, that is called the internal. And you guys are writing this down, right? And then this outside part, I'm going to use a different color. This part, segment EC, is called the external. Okay? And it's called external, obviously, because it's outside of the circle. Okay? So what did this thing say to do? You multiply the secant times its external segment. Okay? So I call this one case number 2. Case number 2 is two secants meet outside of a circle. And this does sound a lot like, you know, the beginning of a joke or something, but it's not. It's very serious. Okay, two secants meet outside of a circle. So we have the circle sitting there minding its own business. Let's name the circle. Let's call it Circle K. And Circle K is just sitting there minding its own business. We have this point outside of the circle. Let's call it point E. And from point E, there is a secant to the circle, right? So there's this like laser beam segment that shoots across two-dimensional space and cuts through the circle at 2 points. So let's name these two intersection points A and B. And E, point E also shoots another laser beam that ends up also being a secant segment to the same circle down here. Let's call these intersection points C and D. Okay. So the moniker that you have to remember here is outside piece times the whole piece. Outside piece times the whole piece, the entire piece. Okay. So that's what you have to do. Okay, for each secant, let's look at the top secant first. What is the outside part, the outside piece of the top secant? It is EA. So we have EA times, now be careful here, it's not EA times AB, it's outside piece times the whole piece. Go ahead and circle that and actually put a star by it, okay, because this is the common student error. Sometimes students forget to multiply it by the whole piece, okay. It's EA times, not AB, it's EA times the whole piece is EB. And that is equal to, same thing on the bottom secant. Outside piece is EC, the whole piece is ED. Okay, so you can see that I'm really emphasizing this whole piece thing. Okay, this is very important. Okay, it's not outside times inside, it's outside times the whole thing. So let's go ahead and do some examples. Okay, right over here is an example. And in this example, it asks us to find the value of x. Okay, so first let's look at the big picture and see what's going on. So here's your circle. It's a nameless circle, unnamed circle, too bad. Okay, and this top piece, RQ, that is a secant. Okay, it intersects at P and Q. This bottom piece is also a secant, and they have a common endpoint outside of the circle. So we know that this is case number 2, two secants meet outside of a circle. Okay, and when that happens, the key phrase is outside piece times whole piece. Okay, outside piece times whole piece. So let's look at this top part, this top secant. Okay, so the outside piece is, first let's use letters. RP is the outside piece times the whole piece is RQ. Is equal to, on the bottom secant, what is the outside piece? That's right, it's RS And then what is the whole piece? The entire secant on the bottom there. It is RT. Good. So now let's just substitute in the numbers that we have, or the values that we have. So RP is right here. It's 9 times, oh, there's an 11. Is it 9 times 11? No, slow down. Okay. RQ is the whole piece. So how would we get RQ? It would be 9 plus 11, which we can go ahead and just do the mental math on that. That is 20. RS is given to us as 10. Now be very careful here. RT, is it X? No, it's not X. Well, what is it then? It's X is just this little piece out inside here, but we want the whole piece, right? Because it's outside piece times whole piece. So the whole piece would be this 10 and this X, or 10 plus X. Okay, so let's go ahead and multiply 9 times 20. That's 180. Now here, you do not have to distribute this 10. Okay, you could just divide out the 10, right? Okay, but I know that most of you feel more comfortable when you see a situation like this. I think that most of you feel more comfortable just distributing that 10. So I'm going to go ahead and do it that way. So 10 times 10, 100. 10 times x, 10x. So now what do? We're trying to isolate the x, get it by itself. So subtract 100 from both sides. Now what do? Divide both sides by 10. Are we done? It said find the value of x. We found the value of x. We are done. Okay. So now let's move on to this next example. Same situation. We have two secants that meet outside of a circle. They intersect outside of the circle, right? So what is our moniker? Our moniker is outside piece times whole piece. Okay, outside piece times whole piece. Okay, so let's go ahead and scooch this up. So on this top secant we have all the numbers, so that's nice. So outside piece is 6. The whole piece is it 9? Nope, not 9. It is 9 plus 6, which would be 15. Bottom secant, what's the outside piece? Is it x or 5? That's right, it's 5. And then what's the whole piece? X plus 5. Alright, 6 times 15. I believe that's 90. And then we could divide this 5 or we can distribute it. Like I said, I think most of you are more comfortable distributing, so I'll go ahead and distribute it. 5x plus 25. Subtract the 25. Divide both sides by 5. And it just asked us to find the value of x, so we're done. Okay, now we move on to the back side, the last case. Okay, the last case. Case 3. Case 3 is a secant. Whoops, I forgot a space there. Sorry. A secant and a tangent meet outside of a circle. So instead of two secants meeting outside of a circle, it's a secant meets with a tangent outside of the circle. And guess what? It's almost identical to the previous case 2, where two secants meet outside of a circle. What was the moniker for two secants meet outside of a circle? Outside piece times the whole piece. Well, guess what? It's the exact same moniker here. So let's just jump straight into the notes. Outside piece times whole piece. Again, let's highlight that if you have a highlighter. If not, circle it, underscore many times, asterisk, star. Okay, it's the whole piece. So let's go ahead and draw this case. Okay, so we have a circle, and let's call this, I don't know, circle P. And it's sitting there, circle P is sitting there minding its own business in two-dimensional space. When along comes point E, outside, E for external, outside of the circle, and it shoots this laser beam that goes through or intersects circle P in 2 points. Okay, let's call those points C and D. So this is a secant, right? And then it also shoots this laser beam up top, okay, up here. That hits the circle in exactly one point, and that is your tangent. Okay, that's your tangent. So you have a secant and a tangent that meet outside of circle. Okay, let's go ahead and call this point A. Okay, so what is the moniker? What is the catchphrase? It is outside piece times whole piece. Okay, let's do the bottom part first. Let's do the secant first. What is the outside piece? That's right, it's EC. What is the whole piece? Be careful, it's not CD. The whole piece is ED. Good. Okay, on this top thing, okay, it's a tangent, it's not a secant. But what is the outside piece? Well, the whole thing is outside, right? So it's EA. So it's outside piece times the whole piece. And what is the whole piece? The whole piece is also EA. Okay? So really, it's very much like the previous case. So this just becomes EC times ED equals EA squared. All right, let's go ahead and do a couple examples.